I'm very proud to present the end of our project, which is in the south of the Netherlands, which is actually a water-stressed area. So there's the groundwater and the surface water is saline, so that causes some issues. And indeed, I work for Rietland, which is a Belgian company who designs and builds wetlands. And I also work for the AZ University of Applied Sciences, which is located in the southwest of the Netherlands. So the topic of the presentation is aerated wetland as innovative pretreatment for desalination plant for chemical industry. Blue, yes. So I'll tell something about Dow Benelux. Dow is the company where we installed the wetland. The wetland you can see on the left side on the picture. Because we have built a pilot, and the idea is if the pilot works, we can run out a full scale, and I can answer the question in the back on how large is a full scale. I'll get back to that in this example. And I'll tell something about the results and the conclusion. All right, so first, Dow manufactures 800 different kind of plastics and chemicals annually. And because of that, they need a lot of water. And what has that to do with climate change? Well, that could have an impact during warm summers. So they take water from the rivers, but if the river discharge is lower, that's a problem. And they could also need more cooling water. So actually, it's a kind of risk assessment for Dow. And they thought maybe we can do something with nature-based solutions. So there it is. So Dow Chemical, Benelux, which is located in the southwest of the Netherlands, uses annually 22 million cubes water. Currently, 75% is already sustainable, but now they want to work on this other 25%. And this other 25% they now get from a pipeline 120 kilometers long, from the Biesbos, which is somewhere in the middle, more or less, of the Netherlands, because that's fresh water. But that also is an area where drinking water is withdrawn. So there's a competition between industry and drinking water. And because of that, they want to stop doing that by 2025. So the alternatives, all right, we're here in the south of the Netherlands, and all the, as I said, the surface water, the groundwater is brackish or saline, so, and there will even be worse in the future if there is more salt intrusion. And they need the water definitely for their cooling tower. So the water for cooling tower is very difficult to create. It's very, and it should be reliable and robust. So they have high standards for the quality of the water there. So what are the alternatives? Well, they came up with this plan. So they want to have the intake of 3 different alternatives. So one is the rainwater from the premises of the Dow site itself. Dow treats its wastewater itself, so from the wastewater there, and also from the Terneuzen city, which is the municipal wastewater. And they want to mix everything and then treat it via ultrafiltration, ion exchange, and reverse osmosis. And then they've got the perfect process water, or the water they can use for their cooling tower. But, of course, there's a but, otherwise I wouldn't be here. The reverse osmosis, the membranes clogged because of, well, there was a lot of biofouling on it, and because of that, there's a lot of costs. You need chemicals and backwashes and so on. So here's the nature-based solution. They placed a constructed wetland in front of the desalination line. That's the idea. So we tested this constructed wetland for 2 years, the pilot, and we tested it separately, but also connected to the brackish water line. Okay, how does the pilot look like? This is a picture. Actually, this is the wetland of Thomas. This is my wetland. Okay, so actually we have 2 pilots. So, and the white bar indicates the separation. So every wetland consists of 3 zones, and we aerate it separately. So it's an aerated wetland. because we have blowers. And in each zone, we place the sensors for dissolved oxygen and temperature and so on. So some figures. So the area is 350 square meters. The depth is 1 meter. The flow 10 cubes per hour. And the hydraulic retention time 12 hours. We have 2 wetlands. So we could put them in series or use them independently. We've planted some plants on it, which are Phragmatus australis, which is common reed. The substrate is Argex, which is aggregated clay, expanded clay aggregates, that's the correct word. And in the second zone here, we have placed 15% biochar to see what the added value of that would be. But the main focus was on to prevent the biofouling on those membranes. So we wanted to check what the nutrient removal would be. So for COD is the organic matter, and then for the nitrogen, more specifically. And what were the options or the settings we could change? We could change these oxygen settings because we are aerating different zones, and we could change the aeration. We could add some carbon. We could put the wetlands in series or not, so double the retention time, and see what the biochar does. Yes. Okay, something about the results. The dissolved oxygen setting was 2 to 2.5 milligram, and that works nicely, so everything is nitrified, and you could aerate more, but that's just a waste of energy. So that's why we kept to the 2 to 2.5 milligrams. Everything is nitrified, which means there's no ammonium going to the desalination line. And it was very important because ammonia is very hard to get out with the membranes. Just to give you an idea, the influent concentration is already low, 3 to 14 milligrams per liter nitrogen, because it is already treated in a wastewater treatment plant, so it's a post-treatment for that. The removal of the organics is only 25%, which is very low, actually, for an aerated wetland. Normally it's 95%. But actually, the easy part to degrade is already degraded in the steps before. So as you can see, but we think that the small fraction, which is still degradable, we degrade in this 25%. And the consequence is that we hope that this has less influence on the biofouling of the membranes. Last, low energy consumption. We were very happy with that. Other results, well, I stick to the nutrient side of this. So we have full nitrification, and then we wanted to see if we have denitrification. So for denitrification, you want less oxygen. You want anoxic conditions, but the consequence is if you have anoxic conditions, then the organics are less removed. So there's a trade-off there. Then we also added a carbon source with a CN ratio of 4. That was perfect for denitrification. Nitrate was out for 60%. We were very happy with that. But if you add carbon, of course, you get more organics again. So there's the trade-off there. And we could see we had some practical problems, and also the ion exchange, which is part of the desalination line, also can get nitrogen out. So that was resolved as well. And then we connected the both wetlands to 24 hours retention time instead of 12. And that also had a very nice nitrogen removal, but that was only during summertime. So to do this on a large scale, it would be not so beneficial in wintertime. So the aim was the clogging of the ultrafiltration and the reverse osmosis. And we could see already, yes, thank you, that the constructed wetland had an impact on the ultrafiltration. So the ultrafiltration runs robust, reliable, less backwashes, chemical cleaning are needed, so lower costs. So the first conclusion is you could say that including aerated wetlands with a short retention times makes sense as a step between conventional treatment and membrane filtration. And now we're looking at if it's possible to run a full scale. So that would be 3 hectares. And that could be operational in 24, 25. But nature-based solution is more than only treating water. That's the aim of nature-based solution. So we also had some biodiversity. The kingfisher sitting on the left side in the picture is sitting on the effluent pipe of the wetland. So, which is a nice example of there was more biodiversity coming in, which is very nice. And there's also some amenity, where the previous speaker, Oscar, mentioned already. And besides that, you have low operational costs. You need less specialized personnel. And we have built a robust system, because sometimes you got the wastewater from the municipality, sometimes wastewater from the industry, and also always the wetland did a really nice job. So to conclude, Dow is very happy with this nature-based solution. It brought some added value, and there was less competition for drinking water, because they resolved that. And just for the future, decentralized treatment is a very crucial step in circularity, in the reuse of water in general. And it's just as a small remark, we are planning an Interreg project between Flanders and the south of the Netherlands to see if nature-based solutions could also be used. Actually, it links to Thomas's project to buffer capacity and treatment. So if partners want to engage in that, just be in contact. So thank you, and thank you all the people, definitely Hafiz Khan, who did all the work.
Thank you, Mireille. And thank you. So I think it was the right place to have your presentation here. It's kind of summing many of the previous speakers also in your presentation. So this is open for questions from the audience. Any questions? I see one hand and don't. Okay, one more hand. Okay.
It's a very nice presentation. Thank you very much. I was wondering what the long-term development of these wetlands is, and if that will require some specific maintenance after some time to really keep up the functioning as well.
I'll now put up the other hood. Rietland built already from 1995 wetlands, and they are still functioning. I think it depends a little bit of what you're aiming for. For example, if you aim specifically to get a certain compound or nutrient out, like phosphorus, there's a saturation, because you resolve that problem via adsorption. Then, of course, after a while, that doesn't function anymore. But normally, yeah, it takes a really long time. Besides that, for the full scale, we were checking if, because we use Argex, so the expanded clay aggregates, and they, after 25 years of work, they can be dig out again, and they can be used for now, currently, for construction, for building material. So still a lot you can recycle on that.
Okay, yeah.
Hi,
hello.
Thanks for a very nice presentation. Actually, I have two questions. On the COD removal, you mentioned it's 25%. Did you check whether that's mostly suspended solid COD, or is it also really the soluble COD that you remove? And my second question is related to the optimization of oxygen input, sea source. Have you considered to first put in an anoxic zone and then the oxic zone and then the recycle? Because it may help.
Let's start with the first question.
Yeah, so the TSS. There's almost no TSS coming in, because, from the biox from the industry, there's no TSS coming in. And from the municipality wastewater treatment, as last step, they have a MBR. So actually, so it was really the COD in the water we measured. And what was the second question?
Sorry. The second question, because you were optimizing sea source dosing and energy saving. If you would put, first the anoxic zone and then the oxic zone with the return.
Yeah. We thought about that. What was the reasoning again? Because we changed a lot of with the settings. So the carbon which is in the COD, which you need for the denitrification, was not so degradable. So you actually, the trade-off was not big enough to do it differently, I think.
Okay.
I'll get back.
Another question?
Yes. Hello. Thank you for the presentation. I was wondering if you can elaborate a little bit more about the biochar that you used, and I assume that based on what I saw, you had 3 different zones, and then on the second zone you incorporated the biochar. So I'm assuming that was a horizontal flow.
Yes.
So have you thought of using a vertical aerated constructed wetland with different layers of biochar and then different clay or other types of sand?
Yeah, no, we didn't. So this is a horizontal subsurface flow because normally you use a vertical subsurface flow if you have a large load. And we didn't have, well, the concentrations are very low, but the hydraulic load is quite high. But still, calculating that, we have chosen for a horizontal one, and not a vertical one. And then the biochar was only placed in the second one because we did this together with the University of Ghent in Belgium. And it was for everybody actually the first time we used biochar. And the results are, were very disappointing. And we think it's because you do like a pyrolysis.
Pyrolysis, yes.
Yeah, on the wooden pallets, and it should be at a certain degree and a temperature. And we think that the pretreatment of the biochar was not sufficient to have any effect. We didn't see any effect because you could see we could bypass the second zone, so to see what the wetland does with the biochar and without, and there was, well, it was not a significant difference.
Yeah, I guess it really depends on the type of biochar that you're going to use, because I know that there are many studies that show that biochar can be beneficial.
Yeah, we read them too, but
I guess it really depends on different parameters.
True.
But maybe related to that question, didn't you see any effect on certain micropollutants that are in the water?
Because we also, we tested that, and well, the ones who are in the literature described as very degradable, like a lot of pharmaceuticals, they went out very easy. Also, E. coli was out completely, which is also interesting. But so we have also checked the micropollutants. But
is that because of the biochar or just...
No, because even without the biochar, only Wetland 1, where there's no biochar in, that also removed all the micropollutants, which are easy degradable.
So there's no clear benefit of the biochar
well, not
in
from
this
this
system.
experiment, no.
Okay.
No.
In other systems, we showed, or it was shown that there were some benefits.
Yeah. So it's typically the type of biochar you need with combining with the substances you want to remove. Okay. Yeah.
So talking about biodiversity of these nature-based solutions, can't you use a mixture of plants, or why do you use only one plant?
Yeah. Well, it's easy. That's one. But no, for the biodiversity point of view, it's a very difficult topic here because the Phragmites australis is very dominant species. So if that's somewhere in the neighborhood, after 5 years, you can design a very nice biodiversity there in the wetland, but after 5 years, it will only be Phragmites. But so we are thinking if we go for the full scale, that we would add next to the wetland other landscapes with a gradient in the slope and different things. So there we would have more biodiversity then.
Yeah, okay, that's maybe my question then as a final question. Couldn't you think about constructing wetlands that are also have a ecosystem variety, a heterogeneity, instead of such a monoculture, and then you have two, well, you hit stone.
Yeah.
Two birds with one stone.
Yeah, exactly. Yeah, not the flies. Yeah, so we are discussing that as well, but it's very hard because previously constructed wetlands, everybody just thought about pollutant removal, and now we're thinking more about biodiversity and different species. But that's also what Thomas said a little bit. So depending on, he talked about salinity. So depending on circumstances, you use different plants, and we know that Phragmites will do the job.
Yeah.
So, but there's a way to go. Yeah.
Yeah. So maybe to conclude this session, then. I think what we saw with Thomas, that we have quite some technologies that are suitable for making industrial waters reusable, using nature-based solutions, but we also need some add-on technologies, like you also showed. And then the presentation of Oscar showed very nice concept of designing green infrastructure systems in the urban or in the industrial environment, and that we can include all kind of non-technical, aesthetic and social aspects in the concept of ecosystem services. And then you came with a very nice presentation that's all ready to go into practice. So the only thing is we need to add a bit more eco to the system, and then we are done. So I think we have a nice set of examples in this session. About the whole track, how to go for nature-based solutions. I want to thank you, Mireille, for your presentation. Give her a hand.
Thank you.